Welcome back, boys and girls. Gary Simmons here for the Game Institute. Now, when we finished up at the end of the last video, we had added this cylinder to our scene. I've called it Agent, and we also added a NavMesh Agent component to it. And we briefly talked about the various settings and how they influence how the agent is going to behave when it's traversing its path. But if we press play now, you're going to see that what happens is rather underwhelming. Absolutely nothing. Nada. Not a goddamn thing. And that's because the NavMesh agent doesn't do anything by itself. It's packed with functionality, but unless we write one of our own behaviors to tell it what to do and when to do it, it's going to be a little bit like having a Ferrari parked on a driveway with a full tank of gas and just staring at it and wondering why it's not going anywhere. It needs a driver, and so too does our NavMesh agent. So we're going to create a new behavior now that's going to interface with the NavMesh agent and tell it to patrol our waypoints. Now, I'm going to create this script in our navigation example folder, and the reason I'm going to create it there is that this is by no means going to be a final script that we're going to use in the game Dead Earth. We can't start writing that until we bring in our zombies and we understand how animation state machines work. But what we are going to do for now is write a script that's going to get us really comfortable with how the NavMesh agent works and how we can get it to patrol our waypoints, process off-mesh links, and deal with the situation where a path might become invalid whilst we're moving along it. So in our navigation example folder, I'm going to right-click and I'm going to create a new C# script, and I'm going to call this NavAgent Example. I'm then going to open that up in MonoDevelop, and there we are. And before we do anything, I'm going to drag an instance of that script onto our cylinder. So we have both our NavAgent example behavior and the NavMesh agent on the same game object. So because our NavAgent example script is going to need to be able to talk to the NavMesh agent on its same game object, it stands to reason that we are going to need to store a reference to that NavMesh agent. So let's make that our first variable. I'm going to make it a private variable of type NavMesh agent, and I'm just going to call it NavAgent. And we'll set it to null initially, and then in the start function, what we'll do is we will cache a reference to it by doing NavAgent equals getComponent NavMesh agent, like so. Now, because this script literally makes no sense if it's on a game object which doesn't have a NavMesh agent also assigned to that object, we can kind of enforce that behavior so that if we ever try and drag our script onto a game object and we've forgotten to add the NavMesh agent, this will happen automatically by Unity. And we do that by giving this class an attribute, in particular the requireComponent attribute. That looks like so, and then in those parentheses we have to put the type of the object that we require to be present, and that's going to be the NavMesh agent. So we do type of NavMesh agent, like so. And if we try and ever drag this script, in fact I'll show you, if we create a brand new game object in our scene just temporarily, as you can see in the inspector it's got nothing but a transform component. If I try and drag this NavAgent example script onto it now, it's automatically also added a NavMesh agent, so that's pretty useful. But slightly off topic, right? So let's go back to our script. Okay, so we've now cached a reference to our NavAgent. Now, one of the things that this script is going to need to be able to do is it's going to need to be able to access the waypoints in a waypoint network. So we need to be able to assign this agent a reference to one of the waypoint networks in our scene. We're going to have a public variable of type AI waypoint network, and I'm just going to call this waypoint network, like so. So if we save that off now and go back to the editor, assuming we haven't got any errors, when we look in the inspector we can see that our NavAgent example script now has this public waypoint network member where we can assign one of our waypoint networks. I'm going to assign it waypoint network 1. And you are reminded that waypoint network 1, if I select it and put it in connections mode, is the one that has its first waypoint in this bottom left room here, and then walks over to this second room. And well, you can see what the shape of that path is roughly going to look like. but we're going to assign it waypoint network 1. So what we want to do now is we also want to have a member that's going to keep track of the current waypoint that our agent is heading towards. So I'm going to make that a public integer. Now don't worry at the moment about the fact that I'm making lots of public variables. I am aware of how unsafe that is, but I'm doing it deliberately because it's an easy way for me to get the variables to show up in the inspector so that when we're running the scene we can see all of the values that are being stored in our variables at all times, which is great for testing. And I don't want to make them private and have to give everything the serialized attribute because it's just more typing and it's going to move me along more slowly. But don't worry, when we get onto writing the actual scripts for the game, all of the members that need to be private will be properly encapsulated and given sort of accessor functions. Okay, so like I said, we're going to make a public int and I'm going to call this current waypoint. And this is just going to store an index into our waypoint network of the current waypoint that we're heading towards. So I'm going to set this to 0 by default. Stands to reason that the very first waypoint we'll be heading towards will be waypoint 0, the first waypoint in our waypoint network. And we also need to make sure actually that if we are inside our start function and we haven't been assigned a waypoint network, there's nothing this script can do, so we should probably just return from such function. So I'll say if waypoint network is null, then just return because we can't do anything else. But assuming we have been assigned a valid waypoint network, what we want to do now is use that current index integer to index into the network's waypoint array and just check that the transform stored there is valid. So let's do that check now, because remember, we may have forgotten to assign a transform. Waypoint network dot waypoints current index doesn't equal null. Then we'll step into this code here. So what we want to do is we want to fetch that waypoint, remembering of course that the waypoint is actually the transform, so it's the position of that waypoint that we need. And we want to assign it to the agent and tell the agent to go there using our nav agent, which remember we cached up above here in the start function. We say nav agent dot destination equals, and then we fetch that waypoint from our waypoint network. Of course, because it's a transform, it's actually the position that we're interested in. And that, my friends, is how easy it is to tell a NavMesh agent to go somewhere in our world. Now, obviously, we have to have a NavMesh baked, but we do. So let me just go back and see all the mistakes I've made. Wow, absolutely none. Okay, so I'm going to press play now, and we should see our agent walk towards that very first waypoint. Look at that. Want to see it again? I bet you do. And because we made current index public, we can change its initial value. So if we wanted to go to that waypoint right over there in the far corner, if I select the waypoint network, we can see that's actually waypoint 5. So no problem at all. We just need to assign 5 to our agent instead, like so. And it should walk from here all the way over to there. Ready to see the magic? Look at that. How easy is that? And when it gets there, it should, of course, stop. Beautiful. So as you can see, just a simple vector-3 assignment to the nav agent, assuming we've got a NavMesh baked, takes our agent to its destination. Now, of course, what we want our script to do is say that when it reaches a waypoint, we want to increment the current waypoint counter, and then we want to move it to the next waypoint in the waypoint network. And that shouldn't be too hard to implement. So here we are back in our script source code. Oh, by the way, you'll remember from the last lesson when we were writing that editor script that we were talking to the NavMesh directly in that instance and calling its calculate path function, whereas when we're using the NavMesh agent, we simply set its destination property like so, and it makes that call and communicates with the NavMesh on our behalf, which is much more simple, obviously. But you could actually do it the other way if you wanted to. You could call the NavMesh's calculate path function, and with the returned path, you'll see in a minute when we look more closely at the NavMesh agent interface that it also has a set path function. So you could calculate the path yourself manually on the NavMesh and then use the NavMesh agent's set path function to assign it that path. Okay, so what I'm going to do now is I'm actually going to delete this code where we set the destination of the NavMesh agent, because we're going to want to do this a lot every time we change a waypoint. And there's also some other housekeeping stuff we have to do. For example, every time we set a new destination, we need to increment the current waypoint index so that we can fetch the next waypoint in the list. But we also need to make sure when we do that, and we increment the current index, that if we step past the upper bounds of the array, or the list in our case, that we wrap that current index back round to 0 again, so that we never try to step outside the bounds of our waypoint list. And because we're going to do this a lot, I'm actually going to put it in a function called setNextDestination, so we can just call that function whenever we need to do that. So I'm going to do void setNextDestination, and I'm going to allow this to take a Boolean parameter that makes it optional whether we actually increment current index every time we call it. Now, the reason I'm going to do that is because although under normal circumstances, once we've reached a waypoint, we would want to call our setNextDestination function, have the current index incremented, and then use that to fetch the next waypoint in our list, with wraparound of course, and then use that waypoint to set the new position of our agent. But there are times when you want to set the target that you're already heading towards. So if we're already heading towards waypoint 2, there are times when we might wish to reset as the destination waypoint 2, and that's when the path becomes stale. Now, the idea of a stale path, which we'll see in more detail in a moment, is, let's say for example we have an agent and we've just calculated a path for it which takes it through an area of water. And that was fine, because when that path was calculated, our agent was allowed to walk through water areas. But let's also say that while it's traversing its path, we decide either via the editor interface or via our code at runtime, we decide to change the areas that the agent is allowed to walk on, and we say you're no longer allowed to walk in water. Now, in that particular case, the path has already been calculated, the agent is heading down that path, but the path is marked as stale. It's a way of saying, look, you've got a path, but it may no longer be valid, or at very least it may no longer be the most optimal route to the target you're currently heading towards. So when we've got a stale path, we sometimes wish to reset the destination of the agent to the same target it's currently heading towards, which will trigger another path search on the NavMesh and get back a more up-to-date path. So in situations like that, when we wish to essentially reset the target the agent is already heading towards, we can just call this function and pass false in as the Boolean parameter. Okay, so the first thing I'm going to do at the top of this function is I'm going to say if we don't have a valid waypoint network, then there's nothing we can do here, return null. So the next thing I want to do is calculate how much I need to increment the current index by. In this particular example, it will either be 0 or 1, so we can just simply check the value of our increment Boolean. So I'm going to say int incstep. Incstep is short for increment step, and I'm going to say if increment is true, then we wish to assign incstep a value of 1, else we assign it a value of 0. And I'm also going to declare a local variable of type transform, and I'm going to call this next waypoint transform and set that to null by default as well. We're going to be using this in a loop in a minute to fetch the next waypoint transform that we're heading towards. So why am I doing this in such a cat-handed way with all these extra variables? Well, I just want to make sure that if we have forgotten to assign any transforms to our waypoint network list, then we step over it. So we're actually going to sort of increment the current index in a while loop, and we're going to say we want you to keep incrementing until you find a valid transform in that list. So if there is a gap in the list where we forgot to assign a valid transform reference, we will just step over it. So to show you what I mean, I'm going to say while next waypoint transform equals null. It means we're trying to search now for the next waypoint we need to head towards. So what we're going to do is we're going to calculate now the index of the next waypoint we wish to fetch from the list. So I'm going to say int next waypoint equals, and then I'm going to say if current index plus that increment step that we've just calculated, which of course would be either 1 or 0 depending on the Boolean value passed in, if it's larger or equal to the count of that list of waypoints in our waypoint network. Remember, I'm doing larger than equals to here, because if we increment current index such that it equals the count of waypoints in our list, then it means that as an index, that's actually one greater than what is allowed. Remember, array indices are 0 based. So I'm basically saying if we've incremented our current waypoint index and it's taken us past the end of the array, then we assign it a value of 0. In other words, 0 is the index of the next waypoint we're going to fetch from the list. Otherwise, it's simply current index plus that inc step. Like so. Sorry guys, I just noticed actually that I've put return null at the top, not return. This is a void return type. I'm sure you were all watching that and just screaming at the screen. So now we have that next waypoint index. Let's fetch the transform from the waypoint network and store it in this next waypoint transform local variable. So next waypoint transform equals waypoint network dot waypoints, and then of course we're using next waypoint as the indexer. So we've used that next waypoint index to index into the waypoint network and fetch the next transform that we're supposed to be heading towards. Now of course we need to fetch its position, but we can only do that if it's actually a valid transform. We may have forgotten to assign a reference to it. So only if it doesn't equal null do we step into this conditional here and we say, well, we now know that next waypoint should be our current waypoint. So we'll say current index equals next waypoint, and we also know that because next waypoint transform is the transform of the next waypoint, we can just fetch its position and assign that directly to our nav agent, or I call it nav agent, but of course Unity terminology it's nav mesh agent. But when I say nav agent, you know what I mean. So we say nav agent dot destination equals next waypoint transform dot position, like so. And we're done here in the case where we have found a valid waypoint, so we just return. Now in the case where this conditional is not executed, it means that we've incremented the current index and we found that there's not a valid transform there. So when that's the case, what we'll do is we will simply increment current index, so that in the next iteration of the loop we have another pop at finding a valid index. So I'm going to save that off. Now there are some problems with this code. It's been very quickly written. For example, were you to run this code and have assigned none of the transforms to your waypoint network, in other words, if your entire waypoint network was empty, then this would actually get caught in an eternal loop and you'd have to actually do a hard shutdown of Unity. But we're not going to do anything that stupid yet, are we? We don't want to sort of get bogged down with creating lots of validation code at this point. Okay, so going up to the start function, we no longer need this code where we set the destination of the nav agent, because we've now got our own function that does this. So I'm going to delete that and then I'm going to call our function to do it. Now I'm going to pass false because this is the very first time we're assigning our agent a waypoint, so we don't want an increment to happen, or otherwise the very first waypoint we head towards will be waypoint 1, not waypoint 0, the second waypoint in our waypoint network. So that's why I am assigning false. And if I go back to the editor now, we can see all of the errors that I've made. Holy cow. No errors whatsoever. Okay, I'm going to set the current waypoint index of our agent back to 0 again. So, you know, it shouldn't behave really any differently to how it did before. We're just going to move from this flag here over to this flag here. So if I press play, let's hope it works. Sorry, what am I talking about? It's not going to move over there, is it? It's going to move to this flag because this is waypoint 0. If I set the current index to waypoint 1, then of course it should move over to that flag I thought it was going to initially move towards in the second room, like so. Yep, that'll work. So what we need to do now is we need to, in an update function, we need to poll to see when our agent reaches its destination, and when it does we need to tell it to go to the next waypoint in the list. Now of course we've already got the function that does that, but we need to find out how we know when the agent has reached its target, and we also need to know other things along the way, such as if the path has become invalid, and we have to regenerate a new path. So in order to do that, we need to go to the Unity documentation, look up the nav mesh agent and get familiar with some of the properties and functions that are at our disposal, because at the moment the only thing we've used is the destination property. So let's see exactly what this puppy can do. So when we look up the nav mesh agent in the Unity documentation, we can see that it has lots of variables. And of course, as we would expect with other Unity components, all of those properties that we can set via its inspector, things such as the radius and the height, the speed, the acceleration, the stopping distance, the obstacle avoidance, quality and priority, these are all also properties that we can set via scripting using the nav mesh agent interface. But there are also many other properties that aren't exposed in the inspector that we can use via scripting, and we're going to talk about those sort of a few at a time. And the first one I want to concentrate on is this read-only Boolean property called hasPath. Now this will be set to true when the agent has been assigned a path. So we know, for example, that when we first press play, before we have assigned the agent a destination, this will be set to false. So it's a pretty good indicator as to knowing when we need to assign a path to an agent. Fortunately, when the agent has reached its destination and its path is complete, this will also be set to false again. So, in other words, we know that when hasPath is set to false, we always have to assign it its next destination. However, things are not quite that simple. You see, the pathfinding system in Unity actually happens asynchronously. That means that when we assign a new destination, it doesn't happen instantly. It could take a few frames for the path to actually be computed. Therefore, we can't just simply set a new destination when hasPath is false. For example, if hasPath is false and we set the next destination, when our set next destination returns, the path may not have been computed yet, and hasPath may still be false, meaning that in the next frame we would call our set next destination again, and of course we would end up basically stepping through many waypoints while we were waiting for the actual path to be computed. So we need to only set the next destination when hasPath is false and there isn't already a path pending. Now fortunately, the NavMesh agent interface comes to the rescue again, because there is another Boolean here, as you can see, called path pending. It basically says that a path is being computed but is not yet ready. So that changes our logic. In other words, we only need to set the next destination when hasPath is false and a path isn't pending. So let's add that logic to our code now. Going back to the script and going to the very top of our class, what I'm going to do is I'm actually going to add two more public booleans to our class. So I'm going to create two public mirrors of those variables so that we can also see what's happening in the inspector. So I'm going to say public hasPath equals false and public bool path pending equals false. Okay, so I'm going to scroll down now to the update method, which is currently empty for this behavior, and I'm going to fetch those two booleans out of the nav agent and store them in our public variables so they show up in our inspector. So hasPath equals nav agent hasPath and path pending equals nav agent path pending, like so. So now, because we're copying those values into our own variables, they're going to show up in the inspector of our behavior. And then what we're going to say is we're going to say if not hasPath and not path pending, then we call our set next destination function. And this time we're actually going to pass in true, which, remember, instructs our function to increment the current waypoint before it fetches it. So this is what allows us to step through our waypoint network. So let me just go back to the editor, check we've got no errors. So far so good. And I'm going to select the agent and just set the current waypoint back to 0 to start with. So what should happen is we should see our agent first of all go to this first flag here, then walk over to this second flag over here. In fact, if I select the waypoint network that's assigned to this agent, we can see the order in which the waypoints happen. So we should go over there, then over there, and so on. But I'm going to keep the agent inspector on the screen so that we can see the hasPath and path pending properties. But let's press play and see if we have our agent now correctly traversing all of the waypoints in our waypoint network. So it should now come over to this one over here. As you can see, has path. Yeah, you're not actually seeing those has path and path pending booleans change at all, because the has path boolean literally only turns off for a single frame and then we set the path again. But we can see, looking at the current index, that it is correctly cycling through all of the waypoints and not missing any. So when it gets to the final waypoint, we should see current index go back to 0 again, and it should come all the way back to this first waypoint in the bottom left room of our level, at least from the perspective of which we're viewing it. And then it should happen all over again. Oh yeah. Pretty cool. So obviously that's going to happen forever if we didn't press stop. Our agents will continually just cycle through their waypoints, and when they get to the final waypoint, they'll loop back to the first waypoint and do the whole thing all over again. I mean, just to clarify, because I probably wasn't clear just now, the reason we weren't seeing the has path and the path pending booleans show up in the inspector is because they only really flick on for just a split second. So they don't have a chance to register in the inspector, or at least not in a way that we would be able to see them, because the inspector obviously isn't being updated and repainted as frequently as the scene view or the game view. So that's why you didn't see it. But trust me, they are working, because if it wasn't working, we would have that situation where we weren't taking into account the asynchronous nature of assigning a destination, and we would be skipping waypoints in the list. Okay, so the next thing I said a moment ago was that it's possible to have a stale path. And once again, Unity's documentation comes to the rescue. There is a boolean called isPathStale. And as you can see, it says in the documentation, when this is true, the path may no longer be valid, or at least optimal. So it says here, look, if there are any changes to area mask of the agent, or if you change the values of any of the nav mesh areas, the costs, or if you change any of the off mesh links, either move them or enable and disable them, then the path is going to become stale, because there may be a better path to get somewhere, or the path that it's taking may no longer be a valid path. So we need to really put that in our code as well. Not that I've got anything in my scene at the moment that will cause it to go stale. So I'm saying, if we don't have a path and a path isn't pending, then we set the next destination. But if that's not true, then we're obviously on our path, so we just need to check that it isn't stale. So if navagent dot isPathStale, then we're going to call our setNextDestination function again, but this time pass in false as the parameter. And you will recall from a moment ago when we looked at that function that means that the current waypoint index won't be incremented. We're essentially saying, please reset the same target, the same waypoint for our agent, so it can regenerate a path to that same destination, but factoring in what may have changed with respect to navigation in the scene. So I could run that, but you're not going to see any difference, alright guys, because there's nothing really. Actually, I'll tell you what I'll do, just to be complete, because you're probably going to want to sort of play around with this script and try all sorts of things. We will also make a public boolean mirror of that as well. I'll call it pathStale, just so that if you're playing around with this script and doing lots of things like that, we can see in the inspector when there's a stale path. So of course I need to fetch that value from the nav agent. So in fact, to test that, what I'm going to do is I'm just going to comment out that code I've just added, the code that regenerates the path if we do have a stale path. And then what I'm thinking might work is, whilst pressing play, if I go to the agent and I change its area mask, so I say it's no longer allowed to walk on water, hey, and there you go. pathStale actually ticked on for a little bit there. I'll do it again, just watch. As you can see, the tick box has come back on again. Now in this particular case, it still continues to follow the path. That's just our way of letting us know it's stale. And of course, that pathStale boolean gets reset to false when it reaches the next waypoint, because we know from our code when it gets to the next waypoint, it resets the next waypoint. So a new path is generated which isn't stale. But it's a good way of testing this. Just, I think you can also do it by changing the area costs as well in the in the navigation area. You could also do it there. So you can see, I'll just try that one more time. If I turn off the water area from its mask, the path stale boolean is true again now until it gets to its waypoint. So just remember, when the path is stale, it doesn't mean that the agent's going to stop traversing it. It just means that it's going to carry on traversing it, but there may be a problem with it, which is a bigger issue, right? Whereas you can see, if I now re-enable the code that resets the target when the path becomes stale, we should see that that path stale barely comes on if at all. So let's press play again. And now I'm going to switch off the water area. And as you can see, it doesn't come on because the moment that path was found to be stale, our code regenerated the path to that point. Just another check just to make sure. Enable water again. Yeah, stays off. So all is cool, and we have correctly handled the stale path scenario. What I'm going to do actually is I'm just going to pause the video here, and I'm going to put some comments to break up some of this code, because all of the functions are starting to merge into one. Okay, that looks better. Actually guys, when I was commenting the code a moment ago, I actually noticed that I had an error in my setNextDestination function, and therefore one of the problems I described with it being potentially stuck in an infinite loop didn't actually apply. I'll just zoom in on it a minute. You can see that when I originally wrote this current index plus plus, I thought I'd put it inside the while loop here, which basically meant this while loop would just kind of go on and on forever. But I'd accidentally put it outside the while loop at the bottom of the function just before we return. But then I kind of figured before I moved it that actually that's a better place to go, as it doesn't actually suffer the same sort of deadlock scenario than if I'd put it in the loop. So the way it works at the moment is when we call it, the waypoint index would be incremented, and if we got back a null transform, we would just increment the current index and return. So the application would carry on working just fine, and then in the update function we still wouldn't have a path, so we would call setNextDestination again, and hopefully it would find a path next time. So it would spread it out over multiple frames, which is actually better, and purely by accident. I wish I'd actually designed it that way in the first place. So I've commented the code so it looks a bit nicer now, and we can see where the functions start and end. Now there's one more status that we need to be looking out for when using the NavMesh agent, and that's the status of the path itself. You see, just because we assign a world space position to the NavMesh agent's destination property doesn't mean that the NavMesh was able to compute a path from the point that we specified. Now, all being well, the path that we get back will be a complete path, but if any of the positions that we've specified are not contained within the NavMesh, for example, we might get back an invalid path, and in that case we would probably want to move on to the next waypoint and try our luck with that one. But there's also a case where the destination point cannot be reached, but a path can be generated that takes us part of the way there, and this is referred to as being a partial path. So if we flick back to the Unity documentation for the NavMesh agent, you can see here that there's a member called path status, and this is an enumeration of type NavMesh path status that will have either one of three values. Now, if for whatever reason the computation of the path completely failed, we will get back an invalid path. It will say path invalid. But all being well, and the path has been successfully generated from the agent's position to its new destination, the path status will be path complete. But there are times, like I said, when we will be returned a partial path. Now, when we get back a partial path, from the agent's perspective, it's still a proper path. The agent will still traverse that path. What essentially happens is the agent modifies the destination point to the point along the path that is the closest it could get to the original destination that we specified. So if I was to go back to our level for just a moment and call up the navigation window so we can see the NavMesh polygons again, a typical example of where we may get a partial path is if our agent was here, where it is now, and we placed a waypoint up on this NavMesh polygon on top of this roof. Now we know that these roof polygons on the nav mesh are not connected to the floor polygons of the nav mesh. So there is no way, without us manually placing off mesh links, for our agent to get up onto that roof and finally reach the waypoint. Now, were we to issue a path request similar to that, what we would find is we wouldn't get an invalid path because the destination couldn't be reached, but we'll get back a partial path. Essentially, the nav mesh will modify the target position that we put in so that the end of the path is now as close as we can get, probably on the edge of the nav mesh right next to this building. Now, we can choose how we handle partial paths. We could, for example, simply say that if the path is anything other than complete, then we just reject it. We're not interested in partial paths, and we'll just move on to the next waypoint. But partial paths are useful. For example, if there was the player on top of this building, although the zombies wouldn't be able to get to the player, it would be quite cool to still have them sort of come and get to the bottom of the building and kind of wait for us to jump down, if you like. So if we reject the partial paths, that won't happen. If a zombie was suddenly walking down this corridor and then we jumped up on the building and then it tried to set the player's position as its destination and got back a partial path because it couldn't reach the player, then it would just turn around where it was and move on to the next waypoint. Whereas we actually may want it to move right up to the edge of this nav mesh and maybe wait there for a while before finally giving up and going on to visit the next waypoint. So let's add some code that's going to deal with the path status. So just like I've done with the other flags for debugging purposes and for experimentation purposes, we're going to create a new public variable of type nav mesh path status, and we'll call this path status, like so, and we'll assign it initially path invalid, although it doesn't really matter, like so. And then in our update function, we will once again fetch the path status from the nav agent and store it in our public variable so it shows up in the inspector. So path status equals nav agent path status, like so. So what we'll do now is we'll go back to the editor, and that second waypoint in our network, we'll actually move it onto a bit of the nav mesh, such as on top of that roof there. So we know that that is a waypoint that our nav agent just cannot get to. And if we select the agent in the hierarchy and select its inspector on the right hand side of the screen, we should see the path status set to path partial once it's reached that first waypoint and it's making way to its second point. What should happen in this case is, like I said, this sort of target destination is going to be modified, and it will find kind of the closest point, at least what it considers to be the closest point that it can get to it. Now, like I said, from the nav agent's perspective, this is still a valid path. So the nav agent, once it reaches that modified target point, it will treat that as if it's reached its destination. So what we would see in this case is, let's just say, for example, the partial path ended right on this polygon here, right on its edge. We would see the agent come around, stop for just a moment on the edge of this nav mesh, and then at this point the path has been completed by the agent, and then we would move on to the next waypoint. So we should see it come somewhere around one of these edges and it can go no further. It will then just move on to the next waypoint, which I think in our waypoint network is this one over here. So let's press play with my fingers crossed, and remember, keep an eye on the inspector, especially the path status, once the agent has reached the first waypoint. There you go, path partial. So let's call up the nav mesh and see where it's going to go. Looks like it's going to take us around that side. Now, as you can see, as it reached the end of the partial path, as far as it was concerned, it had reached its target, and now it's heading off to the next waypoint, which is this one over here. And it's then just traversing our waypoint network as usual. So you can see partial paths are pretty useful. Okay, so all we have to do now is just add a little bit of code to our update function so that we set a new destination if for whatever reason the current path is invalid. So we'll open up another set of parentheses. So what we'll say is what we have already. So if we haven't got a path and a path isn't pending, or if path status invalid, then we call set next destination. So what we're basically saying is just what we did before, but there's a new conditional now which says if we at any point find that we have an invalid path, then call set next destination, which we know will then try the next waypoint. And if that creates an invalid path, then in the next update it will call set next destination again and try the next waypoint. So that should be pretty foolproof. So like I said, at the moment our code is processing partial paths, such as in this scenario. We can see it can't get to waypoint 2, but it'll get as close as it can. Taking a different route now because I just moved that flag slightly. and all is fine. So it just treats it like a normal waypoint, almost as if we've moved that flag off of the building. But let's just see what the code would look like if we wanted to reject partial paths as well. So in this particular case, we would be looking for a behavior where we would navigate to the first waypoint and then we would skip the second waypoint and move straight to the third waypoint, rejecting the partial path of the second waypoint. So that's easy. We just do what we just did, but add another clause, path partial. So now we're saying that we set a new target if we've got either an invalid path or a partial path, or if we haven't got a path and a path isn't pending. Okay, I think that covers all bases. So like I said, what we should see now is we should see that second waypoint completely rejected, and we should just go straight from the first waypoint to the third waypoint. Fingers crossed. Hey, look at that. I properly read what was going to happen there, and that's made me immensely proud. Okay, that's cool. But for now, we will put our waypoint back in a perfectly good position, and I think I'm going to remove that conditional. Well, I'll just comment it out, so that way you can very easily uncomment it when you download the script. Oh, and by the way, these scripts that I write are available for download. So the scripts for this lesson should be in a zip file that you can download from the resources page of the Dead Earth channel. And there should also be a link to it underneath the actual video player as well. And I believe it should be called Navigation and Pathfinding Part 5.zip. Are we really on part 5 already? Wow. Okay, so let's go back to the editor now and just test our original idea that we can have multiple agents with different waypoint networks. So what I'm going to do is I'm going to duplicate my agent 5 times. Well, actually, I'm going to duplicate it 4 times. So there's 5 agents. Okay, there they are. And what I'll do is the middle 3, I'm going to assign waypoint network 2 just by dragging and dropping them into that waypoint network property in their inspector. So agent and agent 1 are assigned network 1, and 2, 3 and 4 are assigned network 2. And what I'll do, at the moment they're all showing the same starting position, so we'll just spread these out a little bit so they don't all start in the same place. I'm pretty sure if I started with one of my nav agents there completely off the nav mesh, that would probably give me an invalid path, right? I'm guessing so. And where else can I put this one? Maybe over there. Okay, so when I press play now, these agents should all go about their business following their waypoints on their assigned waypoint networks. And we should also see Unity's dynamic obstacle avoidance working as well, so they shouldn't be crashing into each other or walking through each other. They should be turned into a little bit of a mess in the corner there, but you know, they are avoiding each other. Not a lot we can do about that. You don't often see it like that, to be fair, but we did get a little bit of a queue building up, didn't we? But it's all resolved now. They're all going about their business, and like I said, we've got 2 waypoint networks in play here, but you could create loads of waypoint networks. So there we go. That idea works, and that's certainly an idea that we're going to be using in the main Dead Earth game. So what I'm going to do is I'm going to remove those additional agents now, and I think what I'm going to do, just for fun, is I'm going to show you what happens if we alter 2 other properties of the NavMesh agent. Now, we know that when we add a NavMesh agent to a game object, the NavMesh agent, once we assign it a destination, takes care of updating the game object. But actually this link is actually quite a small link. The NavMesh agent is actually quite a self-contained object. It adjusts its own position, the position of its cylinder. And then just kind of at the last minute before the update, it also then takes its own internal position and sets the transform position and rotation of the game object it's assigned to match its own simulation position. But we can actually turn that off if we want. If we go back to the manual for the NavMesh agent, you'll notice that down the bottom there's these two Boolean properties called update position and update rotation, which are by default set to true. What we're basically saying to the NavMesh agent is once you've moved yourself along the path to a new world space position and a new world space orientation, please update the position and the rotation of the transform of the game object to which you are an assigned component. But we can turn that off, and that's pretty fun to watch. So let's go up into the start function. And let's just turn off update position and update rotation. So navagent.update position equals false, and navagent update rotation equals false. Okay, so if I press play now, keep your eyes on the cylinder. Look at that. What you're seeing there is the true representation of the NavMesh agent in the simulation. It's just a cylinder that is navigating its way around the NavMesh, blissfully unaware really that it's got anything to do with the game object and the transform of that game object. The only thing that makes our object move is that we set that update position and update rotation to true, which are its default values, and as the final step it just updates the transform with that position and rotation. So if you ever see that happening in one of your games, if you see your zombie not moving but it's NavMesh agent moving, you'll know what you've done. So I'll probably comment those out as well, just so you can have some fun with that and uncomment them when you download the code. Okay, so we're pretty much done now, I think, for this lesson. In the next lesson, which will be our final sort of lesson on navigation and pathfinding for quite a while, we're going to look at off-mesh links in more detail, and we're also going to look at using navigation obstacles, which are what we use to represent dynamic objects in the simulation. Just before we finish up though, do go and have a look at the manual and read all of the various properties and some of the functions. I mean, something that we haven't used in this lesson yet is you can see that there is a stop function, and that basically just stops the agent navigating its path, basically pauses the simulation, and then you can just call the resume function to start it moving along its path again. You'll also see there's a set destination function. This is kind of exactly the same as just assigning the position to the destination property like we've done. The only difference with the set destination function is it returns a Boolean just to identify whether the request was successful or not. And there's lots of other stuff here. For example, we've got the calculate path function, which allows us to calculate a path on the NavMesh, much like we did in the last lesson in our editor script, but we can just store that path for later. The nav agent won't automatically execute it. We're just using the agent to calculate a path, and then we can store it for later, and then when we do want it to start following that path, we could just call its set path function. And there's also other functions here that allow us to do array cast along the NavMesh, that allow us to set and get the various area costs, and a few other things that we'll talk about later. Now, one of the things that I want to talk about is the idea of velocity, which is a property which I'm sure you can imagine is just what contains the speed and the direction that our agent is currently traveling at. But there's also, although that's a read-write property, there's also a read-only property called desired velocity. Now, the desired velocity is the direction and the speed that our agent wants to be going, but because we have various properties like acceleration, auto braking, stopping distance, and angular speed, and things like that, the desired velocity essentially describes what we're trying to attain, the speed we're trying to get to, the direction we want to turn on to next. And of course, eventually the velocity becomes the desired velocity. So the only reason I brought that to your attention is that we're going to be using those two properties later on when we try and link our NavMesh agent and the route animation from our Mechanim state machine together. So I just wanted you to be aware that they exist. And also, this is also worth playing around with. There is a remaining distance property that tells you how far you've got to go until you've reached your target. So that is, in a way, another way that you could identify when you're reaching the end of your path and branch onto another waypoint. And the other one, which is quite cool to play around with, is the steering target. Now, like we said last lesson and the lesson before, when we calculate a path, the path is actually a series of what Unity calls corner points, but they're really just positions in 3D space, and they will actually be vertices on the NavMesh. And the steering target is the very next corner point that you're heading towards. So if you want to do any debugging, you can kind of get the steering target and draw a little ray in the game view from your agent to the steering target, and you'll actually see precisely the next vertex on the NavMesh that your agent is heading towards. And we'll do something like that a little bit later on as well. So I think that's it for now. Like I said, in the next lesson, we're finally going to demystify this whole off-mesh link thing. Those are the only properties we don't really understand at the moment, and there's quite a few properties and functions to do with off-mesh links, and they are quite important. And we're also going to look at navigation obstacles, and that should be it. I mean, provided we can get all that done in the next lesson, we're ready to move on to bringing animations and zombies. Oh yeah, baby. So that's it for now. See you in the next video, folks. Goodbye.